Hello guys, my name is George Banagar. First of all, I want to thank you all for being here today with me. This presentation will be about chill water systems and how the components are put together and the principles of this system. Now, many people ask themselves, what is a chill water system? A chill water system, it's basically an air conditioning system. Just like the one everyone has in their house, just in a bigger scale. Instead of having freon going through the lines and to the evaporator, it is water going through the piping and the loop to cool down the buildings or the spaces, whatever you call it. Also, what are the components and how do they operate or work together? They basically work the same thing like in a residential area. It's just like I said, in a bigger scale, bigger units, bigger components, everything is a lot bigger. Remember, bigger building, bigger components, bigger stuff. That's what it comes to be all about. Okay, chill water system components. The chill water system has a lot of components, and they all very, very complex. Now, how they work together is very simple. First of all, we have a chiller, which is the heart of the system. That's what cools down that water, and it recirculates it through the whole campus or whole building. We have booster pumps, which are recirculation pumps. What they basically do is they recirculate the pump to the building, to the campus, etc. Also, we have a cooling tower, which is basically the condenser in a residential unit or in your house. Water-cooled air handlers, which is the air handler you have inside your house. And something we don't have in our houses is a BMS, which is a building management system. That's a software and hardware equipment that are hooked up to each individual component. Now, a chiller. Here we have a York chiller. Something very very common that every technician sees out there. A chiller is a machine that removes heat from liquid via vapor compression or absorption refrigeration cycle. What that means is that a chiller is going to remove the heat from a space, from a building, from any place or any area that you want to condition. This chiller basically is, in comparison to a residential unit or a house unit, will be the compressor, which is the heart of the system. Now, this chiller is going to cool down the water, and with the help of other components, it's going to distribute it through buildings, or through one building, or through a whole campus. For example, Miami-Dade College, they have 3 chillers. Sometimes they run 1 chiller, sometimes they run 2, sometimes they run 3. It all depends on the climate. Okay. Now we have booster pumps. These booster pumps help the water recirculate through the campus and through all the units. The basic function of a pump is to increase the water pressure or to create a differential in pressure. In order for the water to recirculate, you need a differential in pressure. Now, the cooling tower. The cooling tower, it's a very important, as well as all the other components. It will extract the heat from the spaces. That's very important. If this cooling tower is not efficient or not working properly, there will be no heat extraction or cooling, if you might want to call it, in any of the conditioned spaces or wanted to be conditioned. Cooling tower. This is another graphic of a cooling tower. water cooler air handlers. Okay, this is an air handler just like the one you have in your house. Very simple, but in a larger scale. Here we have a supply duct, a fan. This is a flexible connection. Right here is where the chill water pipes go into. It's the coil. Here we have the filters, like we have in our own house. And here we have a return duct. Okay, lastly, but one of the most important things for this system to work is a BMS. Like I said before, Building Management Systems. All these components, I don't know if you can see them that well, they're hooked up together and programmed to different set points in order for them to obey to the commands they give. And this is another example of a graphics of a BMS system. And this is another BMS sample graphics. In order for all these equipment or all these components to work together, we need a BMS system. Bottom line. So remember, a BMS system is also the heart of the system. No commands, no operation. Well, guys, that's basically it. I hope you enjoyed this presentation and learned a little bit about this information that I have given you guys. Well, thank you all. Have a good afternoon, and thank you for being here. And now to conclude, I will present my audience. This is Renee,
Chris, Omar.
Well, thank you guys, and I really appreciate it.